video today is going to be on greatest common factor. Make sure that you are showing that you are copying down your notes in your vocab sheet that you should have from our sub today so that you can ace our notes quiz next class. Make sure you're taking notes, and if you need extra time, just go ahead and pause it so that you can write down all the notes that you need. Okay, so we are starting off with greatest common factor. Before we can get into what is the greatest common factor, I want us to first talk about what is a factor to begin with. So a factor, we see this kind of in multiplication problems. If I have something, let's actually give us a number. If I have 5 times 10 equals to 50, in here, these two numbers right here, this 5 and this 10, are both called our factors. So we have two kind of definitions for a factor. A factor is the parts of a multiplication problem. I will say a statement. And then we also have a different definition that it is a number that evenly divides into another number. Okay, so that is what a factor is. So greatest common factor is exactly that. We're looking for the greatest, the largest common, what they have in common, and then factor is going to be that evenly divides. So we're looking for the greatest common factor, the number, the largest number that divides evenly into each. So this, as a formal definition, is going to be the largest number that evenly divides by all the numbers. And that is what a greatest common factor is. We are going to be talking about how to do this in 3 different ways. Way 1 is going to be with a list. Way 2 is with a prime factorization tree. And way 3 is with a division method. There are extra videos on all of these in the slides for today. So I'm going to do one example of them in this video, and then you can look for extra help in the agenda for today. Okay, way 1 is a list. So whenever I'm doing a list, we are going to be listing out all the factors, and then we're going to see what they have in common, and then we are going to just choose the largest. And that is how we are going to find the GCF of these. So let's start with these. I got my 36 and I got my 48. So whenever I'm looking for my listing, my factors, we always want to start at 1. Just so we make sure we do not miss any of our common factors. So 36, I know 36 is 1 times 36. 2 times 2 is evenly divisible in here. It ends in a 6, which means that it's even, so it's divided by 2. So 2 times 18. 3, okay, so 3 goes into 36, yes. It goes in 12 times. 4 does 4 go into 36? Yes, it does. It goes in 9 times. 5, is 5 divisible? No, it doesn't end in a 5 or a 0, so it's not 5. And then 6, yes, 6 times 6 equals to 36. Whenever I'm listing out these factor pair trees thing, the factor pair list, whenever I see a repeat, so see how I have 2 6s in here, I can go ahead and stop, because whenever it repeats, that tells me that there are going to be no other common factors. Okay, and now on to 48. So 48, I have 1 times 48. 2, yes, it's even, so 2 times 24. 3, yes, if I look at 8 plus 4, 8, 9, 10, 11, 12. So since 48 is divisible by 12, 3 is going to be divisible by 12. And if you're confused on that, watch the divisibility video, and that will help you. So 3 times 16. Okay, and 4. 48, yes, is 4 times 12. 5, nope, there's no common factor. 6, we know that 6 is a factor because it's a factor of 2 and 3 already. So 6 times 8. And then we go for 7. Nope, 7 is not a factor. And then we'd go for 8, but 8 is already a repeat, so we can stop. Okay, and now, so we have done our first step. We have listed all the factors. Now we're going to look for what they have in common. So they both have a 1, they both have a 2, they both have a 3, they both have a 4, they both have a 6, they both have a 12. Do they have anything else in common? I do not see anything. So the largest number that they have in common is at 12. So we can say the GCF of 36 and 48 is 12. Okay, that is that one. Let's go on to the next one. Prime factor trees. So how prime factor trees work is we are going to be taking our number, our 50, and we are going to be breaking it down into its prime factors. So remember, prime numbers are numbers that cannot be divided by anything other than 1 in itself. So for 50, I'm trying to figure out, okay, what can I break 50 into? I know that 50 is 5 times 10. Since 5 is a prime number, I can leave that one. I can't break 5 down at all anymore. So that one just stays 5. But 10, I can break 10 down. 10 can be written as 5 times 2. So that means that the prime factorization of this is 5 times 5 times 2. So 50 equals to 5 times 5 times 2. And we call this the prime factorization. Okay, and then for our 20, we would do the same thing. We would break it down. Okay, can I break this into any, can I break 20 into anything? Yes, I can break 20 into 2 times 10. Okay, 2 is a prime number, so I can't break that down. But I can break down 10. I can break down 10 into 2 times 5. So that means that 2 and 5 cannot be broken down anymore, so 2 and 5 stays put. And so that means that 20 equals to 2 times 2 times 5. And now for us to find our GCF, whenever I'm doing it like this, our GCF is the product of the common factors. So my common factors in here, I see that I have 1, 5 in common, and I see that I have 1, 2 in common. So that means the GCF of 50 and 20 is going to equal to the product of those two. So 2 times 5, which equals to 10. So that means the GCF of these is 10. Yay! Prime factor tree. And last way for this video is the division method. So for division method, we are trying to divide out any common factors. So I have 40 and I have 64. I'm trying to divide out any common factors. So we're going to divide out common prime factors. So I see 40 and 64. I know that I can divide out of 2 really easily, and that's going to give me 20, and that's going to give me 32. 32 and 20 are both even, so I know that I can keep dividing this out. I'm dividing out the common prime factors. I can divide out another 2, and that's going to give me 10, and this is going to give me 16. Okay, can I divide out anything else? 10 and 16 are both even, so I can divide out another 2. 10 and 16 divided by 2, I get 5, and I get 8. 5 and 8, they do not have any common factors, so they have no more common factors. We stop at no common factors. So in this, we can see that these numbers are the things that we're commonly able to divide out. So this is the common factors. And just like I said in the last one, our GCF is our product of the common factors. So our GCF comes from of 40 and 64, comes from doing 2 times 2 times 2, which equals to 8. So our GCF of these two is 8. So these are just 3 ways to do it. There are extra help videos on these slides. Let me know if you have any questions.